As you might recall, last week I asked you to finish the CAD models for these 3 drawings that were posted on Google Classroom. That's the clevis here, which we did mostly in class. We just left this one hole left for the student, I suppose. There's the stand and there's the bearing cross. And as I may not have mentioned in class, but in the classroom, I made a note. If you had any problems, bring them to this class and we can go over them together. So at the beginning here, I'll just take some time to make sure everyone has these 3 models, that they're able to figure out how to do these things. If they had any problems interpreting anything, anything you want to bring up, I'll be happy to go over together. So just speak up, put a message in the chat, or as you please. If you were able to successfully complete these, also let me know just by putting a message in. And since no one says they have finished it, I can only assume there must be some questions, right? Feel free to ask, don't be shy. Okay, great, 1 person. Anyone else? No questions at all? Every person is finished. Because this time is allotted. I have dedicated this time so that we can go over them together if you have any problems with them. Well, congratulations. Glad it was not that difficult. I see 1 or 2 people have joined since then. So just to give you a review of what just happened, we're taking this time to answer any questions if you had any about how to CAD these 3 objects, 1 of which we did in class, and the other 2 which were left as an exercise. We will be assembling these today in class, so if you don't have the completed models, just say something and you can try to go over whatever you had difficulty with. Okay, just the clevis, that's fine. Does everyone have the clevis done? I know we did go through a fair amount of it. We just have that hole left. I guess everyone is good with that part then. Okay, I'll take that as a yes. So in terms of the other parts, I'll just create a new, I think I was working in here last class. In terms of the bearing cross, just looking at this, I know.
Can you show me?
Pardon? Could you repeat what you said?
How do I do that again? Can you show me?
Yeah, so that's what we're just about to go over. And we'll start off by asking, I guess, those of you perhaps who have done it, what your approach was to making this. Like when you see something like this, what's your first go-to? What thoughts do you have? Yeah, what shapes to use and what shapes do you see? Amy, maybe you can answer that since you volunteered us an answer. Circles, excellent. So we do see circles, specifically we see cylinders, which are, as we know, extruded circles. So we know that we want to have some extrusions in there somewhere. Right now I'm in assembly. I think this is a new part studio. So from here, I know I need a circle and I know I'm going to extrude it. And it looks like I need two of those things. Hopefully, as you can imagine, it forms like a cross. So in a situation like this, and even if you have finished this, I do want you to take a note of this, since I guess my way might be slightly different from what you did, hopefully slightly faster. When you see a part like this, in general, you kind of want to make the origin of your part studio the center of this cross. And that just makes things a bit easier when you're assembling things. And in this case, it makes it easier to model as well. You don't have to do it this way, but I would argue that it tends to be easier if you go about it in this way. So like Amy suggested, start off with the circle. And again, the whole idea of this that is new, the whole novelty is that we're working from a drawing instead of making things up. So we go back to the drawing to see what the diameter of that circle is. And looking both at the side view and this top view, we can see that the diameter of the circle is 0.25. And likewise, the other one is 0.25. And using our lines of symmetry here, we can basically tell that all of these circles are 0.25 or a quarter inch. So we all know how to dimension circles by this point. And so pretty straightforward, I can do that. And what I'll do now is the extrusion. So you also know how to do that, I assume. And there's one thing that I really quickly glossed over. Perhaps you forgot about it. I would have personally myself, so don't worry about it if you didn't do this. But if you click symmetric, what it does is it controls the length of the extrusion in a symmetric way. So basically, the sketch you drew is kind of the midplane or the mirror. You can kind of see how that behaves as I stretch it out or drag it along. Hopefully you get the idea of what that does. And the reason that's useful for us is it can keep the center of that cross kind of at our origin. So next question, how long do we make it? Again, we go back to the drawing and we see 1.5 inches.
I'm confused.
Yes.
So am I just supposed to make a circle?
Yes. Do you have any question about the steps?
So, and also am I supposed to make a new part studio?
Yes, you're making a new part studio.
And is it front or top or right?
It doesn't really matter what plane you use, as there's no like forced orientation, so to speak. This thing is just what it is. As long as you get the geometry right, it doesn't matter.
Front.
So as I was saying, the length of this is 1.5 inches. And you can see what happens when I check this symmetric box, is that instead of just extending it in one direction, it kind of centers it. So now my rod is centered on the origin. So hopefully you can see now that we're essentially halfway done with this bearing cross. We have one of these cylinders, we just need the other one. And the idea with this is exactly the same. So we're just going to do another circle and extrude that circle symmetrically. And what you'll see, I'm just following the exact same steps that I just went through. Again, it's 1/4 inch. And I can, again, extrude that circle, hopefully. Now, in this case, the circle happens to be completely inside of a part, so it won't let me click on it inherently. You can see I'm struggling to highlight that circle. And so what's happening here is that this part takes...
I know how you can do it. Just click sketch 2 and then click extrude. That works for me.
Yeah, there's a lot of different ways that you can do that.
And also, how big is the circle?
These drawings are also on Classroom, as I said last week. Just if you go there, you'll be able to see these
So I
as well
guess
as the drawings that you'll need for next week's homework. So that's all there. In terms of this, yeah, you can do that. And as long as you have like that one closed region in your sketch, Onshape will automatically pick that for you. Other things that you can do, if you ever have trouble selecting something that's there, but it's hidden behind something else, you can do something, I believe, select other here in the middle of that bar. And if I select other, I'm actually able to click on something, even if it's behind something else. So in general, you can use that ability to kind of click things that you don't have access to directly, just by right-clicking your mouse over that point and then clicking select other. And it'll just bring up every possible thing that you could be trying to click.
excuse me,
Yes.
Matt, how long is the tube?
You can check that in the drawing for yourself. It's also 1.5 inches. But if you have any questions about the dimensions, like I've said, it's all in this drawing, which is on Classroom. And so with that, you can go and extrude that other circle. You can use that selection tool like that. Again, I want to check that symmetric box so it centers that extrusion. And the length is 1.5, same as the other one. So essentially, I guess that was a walkthrough of the bearing cross. If you already did it, hopefully, well, maybe this was an easier way to do it. Maybe not. Maybe you found an even better way to do it, in which case, good on you. And so this part is done, and no one said anything when I asked if they had questions with the clevis, so I assume everyone has the holes in there. And we'll move on to the stand, which is the last part that we don't have. This one. So I know at least one of you, based on the chat response, has finished this one, which is great.
Oh my.
Yes.
How do I get it to go both ways? Because it can't go both ways.
If you're talking about centering the extrusion on your sketch plane, you can click what's called the symmetric
Wait,
parameter.
what?
Symmetric parameter here. So it's just a checkbox. If you click it, it will make your extrusion symmetric about the plane on which the sketch lies.
So I guess, but then mine is 3 centimeters long, not 2. I mean, not 1.5.
Right, you can control the depth of the extrusion just by typing in a number.
Yeah, but I can't type in a number that's divided by 1.5. Can I?
You can just type in 1.5 as such. 1.5.
And also, how can I stop myself from seeing something?
The answer to that is almost always going to be this eye icon. So if you hover over the thing that you do not want to look at, on the right, you'll see an eye. So that could be the whole part, which you can hide. It can be, well, I guess can't be a feature, but you can hide and show sketches, and you can hide and show reference geometry.
So how can I oh, I hide it. Cool.
Great. So last part we have is that stand, this thing here. So if you did it, or if you have an idea, what's the first thing that you think of when you see this? What shapes do you see? What features will you use? I want to see a couple answers, especially since some of you are done with it. Jason, could you tell us your approach, how you went about making this?
Well, I would just basically make a rough sketch of it and then just like smooth it out.
Okay, so which sketch did you, like, what did your sketch look like?
Well, basically I made it in a rough shape of it, and then I made and made sure all the dimensions.
Excuse me.
So Jason, what, like, for example, if you think about our orthographic views, like top, front, side, what I guess that's a bit ambiguous since you can't really tell, but sure. So you say that you make like a rough sketch and then you,
Basically make sure all the dimensions are correct, so it looks right.
yeah, sure. I guess that's fair. Do you have a question, Stephen?
Two things. One, how do I make the sketch that I wanted to disappear, like reappear?
Again, as hopefully I've demonstrated, if I haven't, that's my bad. You can just click the eye again and it'll reappear. So wherever you hid something by clicking an eye, you can just click that eye again.
Oh.
Yeah. Right, so.
But it's not showing up for the sketch. It's not working.
I'm not sure what you're trying to show that you had hidden, but.
Oh, actually, no, that is not. Let's delete and just finish.
In any case, as Jason suggested, we're going to sketch it's kind of a rough shape.
Are we going to be using the mirror tool? Like you make one half of it and then use the mirror tool to mirror to the other side.
Yeah, that's a good suggestion. It's an interesting suggestion, and it's definitely something that we can do, especially when it comes to these holes. In terms of the sketch, it depends how you do it. That could make things easier, but I'm going to show you a tool that perhaps is even easier than using the mirror tool for this particular sketch. So to get into it, as was suggested by Jason, we kind of want to go for this rough shape. So essentially we have kind of this bent line. It's like a straight horizontal line and then two smaller lines that come off of it. So we'll start off by drawing something like that. Even though it's like a rough pass, I still want to use Onshape's like implicit dimensions here to make sure this line is horizontal. And it is, you can see Onshape thinks it's horizontal. And whoops, I do want to have those connect. This is the general shape of what that thing is going to look like. Now at this point, there are a few things that I'm going to do to make my life easier later. First of which is to make sure this line segment here is centered on the origin. And as you saw with the bearing cross, just having things centered like that can sometimes make your life easier. So I use the midpoint tool, just take the point and the line. You've seen this before plenty of times, and you know how that works. Next, the same question, how long is it? From the drawing, we can see this part is 7 inches long. So let's start out with that. Put in my 7. Now, what else do we know about this shape? As Stephen observed, we have this mirror line here, and that tells us that everything on this side is symmetric with everything. Like if you took the reflection about this line, it would be the same. So that tells us that this line must be the same length as this line. They must be at the same angle as each other. And it's also good information. So we'll use a constraint to implement it. The equal constraint to be precise.
I'm confused.
So you can see now the length of these two lines will stay equal. So from here, I'll all right, sorry about that. I was distracted by some background, but from here, what we want to do now is basically make this angle so that the shape gets closer to being fully defined. We know that this angle here between this line and this line is 105 degrees. So using our dimension tool, I'm not sure about this, but I think you've seen how we define angles using the dimension tool. If you just click two lines in sequence, one after the other, Onshape will assume that you're trying to define an angle as long as those lines are not parallel. So I'll show that one more time on the right. I click the dimension tool, I click the horizontal line, and I click this angled line, and I can type in a number, which is 105. So that's great. We're almost to a fully black sketch, but we're not done yet. Next thing we want to do is finish off this last dimension. We don't know how long this line segment is off to the side. So we need to give that a dimension. And how long is it? We go back to the sketch. We see this number, it's 3 inches. So I can type that in, and that's that. So here I'll pause for a moment in case you have any questions. But what we're going to go from here is to create this outside part, which is essentially the same shape. In fact, what we can discern is that it has a uniform distance apart. It has that 0.5 inches of thickness. So this line and this line are 0.5 apart. This line and this line are 0.5 apart. And using the line of symmetry, we can determine that this line and this line are 0.5 apart. So last call for questions before I resume this. Right, so what I'm going to show you now is perhaps a new tool. To those of you who did it, I guess if you didn't use this tool, this is a great tool. But it's called the offset tool. You can find it, I guess, between the trim and the mirror tool, somewhere towards the middle right hand of your screen. I guess if you have a really wide monitor, maybe it's on the left part of your screen. In any case, what this does is it creates an offset. So it creates basically kind of a tracing of the things that you select, but at a certain distance away from the original. So it's a bit hard to describe, but when I start doing it, you'll see what I mean. As I click on things, it allows me to essentially offset that. So it's kind of creating a trace that's a distance away from it. So if you didn't use this tool and you did do it, well, now you know. But the point of the exercise, the point of the homework is that you try these things for yourselves because that's really the best way you can learn CAD. Honestly, the only way to learn CAD really is to just try things on your own, discover the limits and the powers of your CAD package, and go from there. So hopefully, even if you now think this is a better way, you still learn something from doing it another way. And hopefully you can understand how to use that tool. I may be going through this fast, or I may not be. But all I do is click these 3 line segments, and these 3 line segments appear. Just like for extrusions, I have this little arrow that I can kind of drag around, but also have this number. So I like this for now. So I'm just going to left click in the background, and that will kind of solidify what I just did. You can see the arrow disappears. I can't drag it anymore. It's solidified now. It's kind of in there. Now it prompts me for a number. So this is kind of asking for how thick I want the offset to be, or what distance I want that offset to be. And as you might recall from the drawing, that is 0.5 inches. So 0.5, I'll type that in and I get this. So briefly, I'll pause here. If you have any questions about the offset tool, I know it's kind of like the sketch pattern tool where there's a lot of things going on and it might be a bit confusing, but there's really not that much to it. Everyone's fine with the offset tool. I will take no response as the affirmative, that you're all good. In which case we'll bring it to almost the last step, at least of the sketch. You can see that this point is still blue on both sides. So our sketch is not done yet. It's not fully constrained. And as we do, we can always drag around blue points and try to see what's not fully constrained about them. In this case, it's kind of the length of this line that's not fully constrained. So what do I know about how long this should be? Well, if I go back to my drawing, I actually don't immediately know how long this line from here to here actually is. I could do some trigonometry real quick and try to figure it out, but it's not really necessary. Rather, what I'm going to do here is make use of kind of this fact that the distance from here to here, this line segment is 0.5 inches. So in this case, you could argue that there's a bit of ambiguity with the drawing, and I might honestly agree with you, but the leap of reason perhaps that we're going to make is that this little cap here that connects the two lines, if I were to draw like a line between this point and this point, the final fact that we're going to use is that it's perpendicular. So I believe actually that might be ambiguous in the drawing. And in those cases, I'd probably either make a note on the drawing that these are right angles, or I just call it out as a right angle, and then it would be unambiguous. But it seems like some of you at least were able to do it, so good job making that pretty reasonable assumption. I mean, honestly, that's what I would do as well in that situation. So the last thing we need, as I said, we're trying to make it perpendicular. So I'll just use a perpendicular constraint, which I believe we've used before, where you just need to pick two lines and they become perpendicular. Likewise, I repeat on the right, draw this, then create my perpendicular constraint as such. And so this completes this particular sketch. As you can kind of see, we drew out that rough shape, those three lines, and starting from there, we used a couple tools to get us the rest of the way there. So if you have any questions about this up to here, let me know. If not, I'll assume we're all good. Incredible. So last two things we have. First is to make this a 3D object. So we need to know how deep to extrude this. In our case, we look at the drawing, we see 2 inches down here. So we take the extrusion, just make it 2 inches. No need to do much else. This is very straightforward, just one extrusion to get this shape. And the last thing we need to do is make the holes. So these holes over here. Here again, you might have missed this, but on this side, there's a center line here, and we kind of dimension from the end to the center line. So maybe not the most clear way to create this drawing, but that is how I created it. What we observe is basically that this hole is in the center of this inside rectangular surface. And when it comes to drawing circles on the center of rectangles, now we've kind of done that 3 times, I believe, maybe 2 times, for one for the slider on the ellipse trammel, and in a sense also for the hole in the clevis, which y'all did. So that's fine. I'll create a sketch right here, just on that plane, in case you didn't catch that. You can create a sketch, and when it tells you to select a sketch plane, you can just click on this face that you want to draw on. So this interior rectangular face is where I want to draw. Here's a quick tip. If you're ever trying to sketch on a surface, on a plane that is not one of the default top, front, bottom, left, right, am I missing one? Top, front. If you're trying to align your camera with one of those, with something that's not one of those, when you're in the sketch, all you have to do is right click and click this bottom option, view normal to sketch plane, and that just aligns your camera so that you're looking head on into it. In this case, I kind of want to look at it from an angle here. And so this is exactly what we've done before, just drawing a circle on the center of a rectangle. So by now, hopefully, having had multiple tries of doing that, you know how to do that. I'll just use a method of creating guidelines. But you've seen me do this like a couple times, so hopefully you see where I'm going with it. Make them construction lines since they aren't really in there. Use my constraints. In that case, I got the wrong constraint. It's supposed to be horizontal. This one to be vertical. And finally, the diameter of this hole is, as I can see here, 0.375 or 3/8 of an inch. .375. So there you go. I'll give you a second just to, again, ask questions if you have them. Okay. And as you might imagine, we extrude the hole, set it to the remove option. And that will create a hole rather than add material. So, I mean, you've done this before as well, so nothing new here. It's all things you've seen before. And we've created that hole. So now we're really almost there. Just one more thing that needs to be done, which is create the other one. And now we can kind of use the strategy that Stephen mentioned, which is the mirror tool. So in terms of the sketch, we ended up not using it, but in this case, it could be useful, especially since we did this thing where this plane kind of cuts the thing in half. So I can't recall if we've used this together, but I think we have used the sketch mirror tool. Who's to say? In any case, the important thing here is to change it from a part mirror to a feature mirror. It's very important. As you can remember from the patterns that we did, the linear pattern and the circular pattern, there you also wanted to change it from part to feature. Then you click in this box, features to mirror, make sure you click on that and you select the feature extrude. Whichever extrusion was your hole, you select that as your feature. Next, you click on the mirror plane box. Make sure to click on this. And this is just basically what the mirror would be, in which case, for me, is this plane right here that kind of divides this thing in two. And fortunately for me, this actually worked. It's almost expecting it to not work because it doesn't sometimes. You never know why, but happily, we're here and we've now concluded the part. So this is all done. So at this point, I assume all of you who did not do it for homework have managed to get a document that has these three.
Excuse me?
Yes.
Two questions. How big is the hole and how thick is the piece?
When you refer to thickness, are you talking about this length here?
I mean, how much is it extruded by?
Right, so you mean this length here, like the length of that line, essentially. So maybe you don't have like access to the drawing at the moment, which is fine. Just make sure you have it after this class so that you can do the homework. Maybe take a look at this for a second and maybe you can answer your own question. Leave it up for a few seconds. Anyone else who has questions or needs time to catch up, take this time to do so. So the next thing we're going to do is assemble this thing. So be ready for that. All right, so I'm going to move over to the other document. I know I can assure you that it's exactly the same thing. I use the same drawings. In fact, I made the drawings using this one, so it must be correct.
Excuse me?
Yeah,
I
sure.
missed it because I went to the bathroom. So what are we at? I missed it.
Yeah, just take, if you got the dimensions, let me know.
I need the dimensions.
Right, so you can get them from this drawing, which I'm sharing screen.
I can't.
Can you not see the screen share?
Oh, let me go. Yeah, I can't. That's because you're sharing your screen and I can't cross it.
I mean, looking at what I am sharing on my screen, can you figure out what the dimensions that you need are? And like I said a couple times, make sure after this class that you can access the Google Classroom.
Yoga.
All right, so at this point,
Excuse me, I didn't hear that. I grabbed it was in my room.
So you can take a look at what's on my screen, maybe take a screenshot so you can look for the dimension as I talk about the next thing.
How thick is the thing? How thick is the thing?
All right, so I'd suggest just take a screenshot right now.
I do not know how to take a screenshot.
Okay, if you have a print screen button on your keyboard, you can press that. If you're on Windows, there's a snipping tool.
I'm on app. I'm on an Apple computer.
In that case, I can't help you. I don't actually know, but you can come back and do this later. Are you still here? Seems like you've disappeared. Well, if you watch the recording, by that point, hopefully you have access to the Google Classroom. Right, Amy in the chat says do Command-Shift-4. It works on Apple, so thank you for that. Spreading new knowledge to everyone, including me. So before we go into the assembly, it's a bit of more talking that I'm going to do about assemblies in general in CAD. So hopefully you'll see the slides. In terms of,
I am very confused until,
all right, so what I recommend is to watch the recording of the class, or after the class, just go to the Google Classroom and look at the drawing, and all the information you need is there.
Excuse me.
Based on the time that we're running, we probably won't, we may or may not get to the assembly in this class. So it'll be an exercise for you, just like the modeling was, for you to do in between. And there's one other modeling exercise that I want you to do for our next class to kind of start off our project 2, which is the air engine. So in terms of that, you can go to the classroom afterwards. I do want to get this in on assemblies. And just to start us off, the idea of an assembly, hopefully you're somewhat familiar with from the previous class, as well as, I guess, just from the previous class. But the idea is that with Part Studios, we're only representing the geometry of a single part. Usually, for what we've done, we only have single-bodied parts. So everything in the part file is a single part. It's the idea of the assembly, the power of the assembly is that it allows us to represent more than one body, more than one part in the same space, and also to define a relationship between how these parts can move with respect to each other. So if you were in the last class, like the CAD 1 class, I made some comparisons to these made to like glue, like the fasten is like glue. And then we've started to go to more complicated ones since then. But the whole idea of the assembly is kind of defining how things are allowed to move. It's a set of rules. And so I'll take a moment to briefly go over some of the options that you have. If you take a moment to go to the classroom and you click on this week 3 slides, the first link in there is actually to an Onshape document. Yes.
How do I do it again?
Pardon? So what you want to do is go to the classroom, click on week 3 slides here,
Let me see.
and go to this link. And if you go to this link, if you can't do it right now, just look at the screen share. I will demonstrate each of these, but if you want to do it on your own, you can use the link in the classroom. So the first mate we have on the slide, you can see we have these 2 parts. One of them has like a cylindrical boss, one of them has a cylindrical bore. And the idea with the fasten is that we're gluing the parts together. So you've heard me say this before, it's like the Legos. You can see from here that these fastened parts can't move with respect to each other. They're glued together.
Excuse me.
Yes.
But what is the class code?
Pardon?
What is the class code?
Yeah. Put that in the chat. So did last class as well. There you go. Hopefully you can see that. But you don't need it at this moment. Just make sure you can do it by the end of the class. Right, so that's the fasten mate. Next is the revolute mate. So this one you've also used before for the sprocket machine, as well as the ellipse trammel. revolute essentially allows rotation and nothing else. So it can't slide up and down along the axis. It can't move beyond the axis. It's constrained to the axis, but it can spin freely. So you can see in this demo assembly, all I can do is spin this little handle. I can't move it up or down. I can't move it left or right, side to side, front or back. All it does is spin.
Never mind. We'll talk to
That's the idea of the revolute mate. Next is the slider. This one we've also used for the ellipse channel, where we had, in fact, what we call the sliders that were in their tracks. And so the idea with these is that you can only move along an axis. You can only move in one direction. So there's no spinning involved. There's no side to side or up and down. There's just back and forth along that axis. So a good way to demonstrate this is third assembly in this linked document. We have our piston and cylinder. This thing is the piston. This thing is the cylinder. And you can see the only motion that I'm allowed to do is along the axis. So only along the axis. I can't move left or right. I can't spin this thing. All it does is move, slide. So there you go. Next one, this is one that we have not talked about. It's called the planar mate, and kind of constrains an object to a surface. So I can think of it kind of like a air hockey table, where you have a hockey puck on the table. In the ideal form of the game, where you're not doing any fancy tricks, the puck lies on the table and doesn't leave it. So you can see that's the kind of motion that we're allowing here. The puck can slide along the table, but it can't move up and down. It can't leave it. And in fact, you can't tell, but it's not rotating either. So that's a new one. That's called the planar mate. And one last one is the cylindrical. And this one is kind of a combination of the slider and the revolute mate. So you can see that it allows for spinning, but it also allows for sliding. So I can move this up and down, kind of like the slider mate, but I can also rotate it like the revolute mate. Maybe hard to tell exactly what's going on, but there you have it.
Well, from what I've seen, it's a blade moving up and down, slicing different types of people.
Yeah, so unfortunately, my control of Onshape is not the best, but I can also animate it and make it go slower. You can see I can choose to animate 2 degrees of freedom, since this has 2 degrees of freedom. It can rotate, which is the 1st degree of freedom, and it can slide, which is the 2nd degree of freedom. You can see the first form, rotation. This is like the revolute mate. In fact, this is exactly what the revolute mate does when you just look at this 1 degree of freedom. But then if I animate the other degree of freedom, which is the slider, you can see that it slides. So this is exactly what the slider mate does. And the cylindrical mate, you can imagine in Onshape, is the combination of these two. It allows both of these, both the sliding and the rotation. So hopefully that very slow animation transmits well by this format. And as you can tell, kind of from the Onshape assembly workspace, there is a lot more. So we looked at fasten, we looked at revolute, we looked at slider, we looked at planar, cylindrical. There's quite a few more things here, but we're not going to go through all of them today. Just know there's like the pin slot one, which acts like a pin in a slot. There's a ball mate, which kind of acts like a ball joint. Parallel mate. To be honest, I believe this one is defining the distances, but I'd have to honestly get back to you on what exactly this does.
I think somebody's unmuted.
Yeah, if you are unmuted, I'd appreciate it if you did mute yourself. Thank you for that comment. There, all right. In any case, the idea is that there are a lot of built-in mates that allow you to define certain predetermined sets of motion. If you look at other CAD programs, they'll often have different ways to go about this. So not every CAD program will have the exact same names and the exact same functions for how these mates work, but these are fairly standard ones. Like you'll probably see like some form of the fasten mate, you'll probably see some form of a revolute mate, and the other ones, if you understand these, you'll pretty much understand how they work. One last thing I will say about patterns is, well, one last thing I will say is about patterns, and that is that you can also pattern in assemblies. And this you can see exhibited in the last demonstration assembly in that link on Classroom. Assembly 6. And what you'll observe here is that we have these two parts, the block and the peg, and we create this one mate between this block and this peg. Then what we do is we circularly pattern. You've all worked with circular patterns before with the sprocket. We make a circular pattern of that peg, which has a mate associated with it. And what happens is that all four of these will behave the same way. So I'm only clicking and dragging one of these, but all four of them are moving along. So all four pegs follow the motion of that one peg. So you can imagine lots of things you can do with that. Yeah, there you have that. Next thing, in the previous instance of this class, we had not done the dual mounting machine, the ellipse trammel in the first class, but we actually got through that. So good on us, I suppose. And the task we have at hand now is to assemble this universal joint so that it works correctly. And by correctly, I'll show you what the thing is supposed to do. This is my completed assembly. I assure you that all of these are exactly the same as the drawing because I created the drawings by using the parts that are in this assembly. So they must be the same, right? Okay. So to give you an animation, I'll animate the rotational degree of freedom. I guess I'm kind of spoiling it. Pretend you didn't see that. But I'll give you a few seconds to appreciate what's going on here. Your task is to assemble these parts that you just created such that it can move in this way. So I'll let it play for a few more seconds. We probably won't finish this during the class. And like we did last week, the homework, part of the homework will be for you to finish assembling this thing on your own. Just try your best. Start of next class, I will take a bit of time to go over it. Hopefully I won't have to go through every single step, kind of like we did this week, but I believe that given that you have experience assembling both the ellipse trammel, the sprocket machine, at least those two things, and knowing what you know about these new things, that you'll be able to achieve this. I will forewarn you that when you work with assemblies, just like with every other part of CAD, there's a lot of frustration that can be involved. Things will break, things won't work the way you expect them to, and that's completely normal. Just understand that sometimes the geometry doesn't just go the way you want it to, and part of the process of being good at CAD is figuring out what to do in those situations. So with that, that is the first part of the assignment. And since we have 5 minutes left, I'll first introduce the other exercise that I want you to complete for the next class. And that is another modeling from a drawing exercise. So first finish that assembly, and then I want you to create a model of a base. And what is this a base for? If you go to the classroom again, the last post that I made gives you first a PDF with some drawings in it and a link to where those drawings came from, which is this website, littlemachineshop.com, where they have these schematics essentially for this little air engine. So if you built this in real life, you could make it spin, make it do some work like a real engine. But we're relegating this purely to the CAD realm. But for the next few weeks of the class, you'll end up modeling all the parts that you see here that are also in the drawing. And the first of those will be the base that I do want you to do for homework. In the next class, I'll actually end up going through one or two of the different parts, but there are like a lot of parts, there are like 7 or 8 of them. So we do need to kind of move through these. So do try your best to complete this base for homework. One thing that I do want to point out right now, since I know you probably might have a question about it, is first of all, if you open this PDF, the drawing, if this is too small for you to see, it's the third one down. This one is the same drawing. And the other thing, you might ask, like, how do I know the dimension of this counterbore thing? Don't worry about the counterbore. Like I said in the slides, don't worry about the counterbore. You can just make it a whole of the dimensions that are given nominally here. Just make it a single hole. Don't worry about doing this layered thing, which is called the counterbore. If you really want to, you can try it, but since we're not making this thing in real life, it doesn't really serve a purpose for our purposes, right? Of just making a model. So the main exercise is just more practice reading a drawing. You're going to create this plate. You're going to locate these holes, and again, this can just be like a single hole, just a single normal hole with this diameter. Don't worry about the shape. Don't worry about the counterbore. So with that, hopefully everything's clear. Next class, I do want to see like your best attempt at assembling the U-joint. And I do want you to have this plate done. And next class, we'll start working on some other parts of the engine. And hopefully in a couple more weeks, we'll be done with the engine and you can have that to play with. I guess before we part, in terms of assembling this thing, you might think to yourself, oh, there's what, 4 parts here, but we only made 3 parts. These 2 are exactly the same part. So when you create the assembly and you import your parts, what you can do is, put in a bearing cross, put in a clevis, put in a stand. That's 3 parts. And then the 4th one, you can actually just do this again. So click the clevis again, put it in, and now you have everything you need. So there's the 2 clevises here. There's the bearing cross, there's the stand. I guess it's not too much of a spoiler. The way I did it, I had 1 fasten mate. So that's kind of to fix this whole
So are we
assembly.
finished with the project?
You will be by next class once you've assembled this thing.
Okay.
As I was saying, there's a fasten mate to make sure the assembly has a fixed location with respect to this origin. There's 2 revolute mates, which, it's up to you to determine how to use them. And there's 2 cylindrical mates. And you kind of need the cylindrical mates to be cylindrical mates. In theory, you can do it all with revolute mates, but you might have to do a bit of tweaking, and it's a lot easier to just use cylindrical mates where needed. So, in fact, I believe this could just be 4 cylindrical mates, no revolutes. So with that, it's 9:30. So see you again next week, same time. Hopefully, I'll be somewhere else and not here, physically speaking, like where I am. But if you have any last minute questions, now's the time. Otherwise, we are done. everything's on Classroom, as I've said. Yeah, sure. So Jason says he is done, which is pretty nice. I guess this class you kind of were bored, not doing much. But yeah, it looks great. So you're animating it. Looks great, it spins. So nice work there. You can focus on like the machine shop, like little machine shop engine drawings. If you really want some challenges, maybe try working on some of the other parts in that, at that link in that like PDF document. Otherwise, I'll probably go home. So